Welcome back, my dear students. In the previous class, we completed the second major concept of light, which is nothing but a refraction. So, we discussed about the refraction. So, what is a refraction? Refraction means when a light ray travels from one medium to another medium, the speed of light decreases due to the change in the refractive index of different mediums. Then there is a bending of light happens, and this phenomenon we'll call it as a refraction. Right? We discussed earlier about it, and we also discussed about refraction at plane surfaces. So let me revise those ones. In a plane surfaces, if the situation is that we discussed about rarer medium and denser medium. What is called a rarer medium? Rarer medium means if light ray, if the speed of light is more in a particular medium, and that medium is considered as a rarer medium. If the speed of light is lesser, and that medium is considered as denser. So let's say when a light ray travels from, let's imagine a line, imaginary line is a normal, and this is interface. Right? First situation, when light ray travels from rarer to denser medium, the light ray bends towards the normal. And in this situation, angle I is greater than angle R. We discussed about this. And second situation, rarer to denser. When a light ray travels from denser to rarer medium, the light ray bends away from the normal. In this situation, angle R is greater than angle I. So third situation, if a light ray travels from denser to rarer medium, right? Denser to rarer medium. Okay, rarer to denser or denser to rarer, anything else. But if the light ray that passes directly through the normal, what happens is there is no bending of light happens here. Angle I and angle R both are equal to 0. Right? You have to we discussed already. And number 4, when a light ray at a particular point of incidence, while it is traveling from denser to rarer medium, what happens is the refracted ray grazes through the interface, right? So the refracted ray grazes through the interface or passes through the interface, and that point angle of incidence is called critical angle. We discussed earlier, critical angle. So now tell me what is called a critical angle. At a particular point of incidence, the refracted ray grazes through the interface, and that angle of incidence is called critical angle. So what is going to happen if we incident light ray, that too greater than a critical angle? If angle I is greater than critical angle, now what is going to happen? If angle I, which is greater than a critical angle, then the light ray comes back to the same medium and with same angle of incidence, which means angle I and angle R both are equal here. And in this situation, this phenomena of light possesses here, we'll call it as a TIR. What is called TIR? Total internal reflection. What is it? Total internal reflection. So did you get it? So now also we discussed about the applications of total internal reflection in the previous class, right? If you have any doubts regarding all these things, and we have already discussed about this much slower in the previous class, right? So go and watch that video and before coming to this video. So in that video, I forgot to explain some concepts like laws of reflection, laws of refraction. So what are those laws? Just like the earlier, just like the laws of reflection, here also we have two laws for refraction also. So first law of refraction is incident ray, refracted ray, and normal all has to lie in a same plane, right? Incident ray, refracted ray, and normal lie in a same plane. So coming to the second law. Second law says Snell's law. Which law? Snell's law. Here Snell's law says sin I by sin R is equal to constant. You have to remember it. Sin I by sin R is equal to sin of angle of incidence to the ratio of sin of angle of incidence to the sin of angle of refraction is constant. So you have to remember this. So this is Snell's law. Newton's second, not Newton's second law. It's laws of refraction. We have two laws for refraction we discussed earlier. So now let's move on. So let me tell you one thing now. We'll call it as a refractive index. What is it? Refractive index. So refractive index is represented by the letter N, and in some books it is represented by mu. Right? Nothing will be possible. But 10th class textbook it is represented like this, and coming to the intermediate it is represented like this, mu. Right? So nothing to worry, both are same. So let's discuss what is the refractive index. Refractive index means it is the ratio of a similar quantities like n is equal to a ratio of speed of light in vacuum, which means the speed of light in vacuum to the speed of light in a particular medium that you want to measure, speed of light in a medium. Did you get it what I'm saying now? N means refractive index. Refractive index is the ratio of speed of light in a vacuum. Here speed of light in vacuum is represented by C, and speed of light in a medium is represented by the letter V, right? So if you simplify this formula, you will get N is equal C by V. So this is the formula for refractive index, right? Here speed of light in vacuum value is always fixed value. So we'll consider C as a constant. C as a constant. What is the value of C? Means the speed of light in vacuum is 3 into 10 power 5 kilometers per second, or 3 into 10 power 8 meters per second, or 3 into 10 power 10 centimeters per second. It just depends whether he is asking this thing like this. Sometimes they are going to ask like this: 3 lakhs kilometers per second, 3 lakhs kilometers per second. So all these things will be same. So you have to remember what is the value of speed of light in vacuum. So n is equals 3 into 10 power 5 kilometer per second divided by, if you consider air has a value that is 2.99 into 10 power 5 kilometer per second. Which means if anyone asks you what are the units of refractive index. So here refractive index is the ratio of two similar mediums to same mediums, right? Same mediums have same units, so both get cancelled. So refractive index have no units. This is most important question for 10th class, because always he is going to ask what are the units of refractive index. Don't write any unit, because refractive index have no units, because it is the ratio of two similar quantities, which is nothing but it's a speed, it is also speed. It is the speed of light in vacuum, it is the speed of light in a particular medium. Did you get it? Okay, that's it. So this is all about refractive index, and refractive index sometimes they might change this refractive index into absolute refractive index. Both are same. Absolute refractive index, both are same. Okay, don't get confused. Absolute refractive index and refractive index both are same, which is nothing but n. N means refractive index. Does refractive index have any units? No, it doesn't have any units. Did you get it? Okay, so let me introduce the lenses now. After introducing the lenses, we'll complete the ray diagrams. After completing the ray diagrams, we'll discuss about the problem section. Yes? Okay. Wait a minute. So here, in your 10th class textbook, they had given some mediums along with their refractive indices and their optical nature. Right? We'll discuss about those. Let's say if we have a vacuum, this is not given in your textbook. So this is medium. So different types of mediums and their refractive index n value. So you need to remember these n values. So the refractive index of vacuum is 1. The refractive index of air is 1.0003. The refractive index of ice value is 1.31. I am not writing any unit because refractive index have no units. Right? Next, water refractive index is 1.33. Alcohol refractive index is 1.36. Kerosene refractive index is 1.44. Then fused quartz. So fused quartz refractive index is 1.46. Turpentine oil refractive index is 1.47. Benzene 1.50. Crown glass refractive index is 1.52. So these are all the mediums that he had given already. And Canada balsam, the refractive index is 1.53. Rock salt, refractive index is 1.54. Carbon disulfate, refractive index is 1.63. Flint glass, refractive index is 1.65. Ruby, most important ruby, 1.71. Sapphire, refractive index is 1.77. And finally, diamond refractive index is 2.42. Right? If you observe the values, he had given the values from 1 to 2.42 up to here. We have different mediums likewise, but he has mentioned only some of the mediums that are related to your topic now. So here you need to observe one thing, that if the refractive index value is more, keep that in mind. If the refractive index is less, let's say refractive index of ice is 1.31 and the refractive index of diamond is 2.42. Right? Let's compare these two first. So ice refractive index value is 1.31 and diamond refractive index is 2.42. So what is the meaning of this value? So this value says if the refractive index is lesser, then the speed of light is more. What is it? Speed of light is more, which means in which medium the speed of light is more, ice or diamond? In diamond, the speed of light is much lesser and the speed of light in ice is much faster, more. That's because refractive index value is in ice is 1.31, which is lesser than compared to the 2.42 value. So what does this refractive index says means ice has a lesser dense, ice is less denser than compared to the diamond medium, which means n value is higher, lower in ice, n value is higher in diamond. So diamond refractive index value is 2.42. You need to remember it. Ice refractive index is 1.31. So here, which is a denser medium, which is a rarer medium? By looking into the refractive index value, you could easily say if it has a higher refractive index value, then that medium is denser medium. If it has a lower refractive index value, then it is called a rarer medium. It just depends on it. So let's consider two more. Let's say I have air and ice. Let's compare these two values. Air refractive index value is 1.003 and ice refractive index is 1.31. Now tell me which is greater. Yeah, ice refractive index value is greater, so ice becomes a denser medium now, and air becomes a rarer medium. So tell me, in which medium the light travels much faster? In which medium light travels much faster? In air, light travels much faster, because comparing any two mediums, it just depends. If it has a lower refractive index value, then the speed of light is more. If it has a higher refractive index value, then the speed of light is much lesser, right? So we'll have some problems that are related to refractive index. So let's start doing them. So keep that in mind. Higher refractive index, light travels slower, right? Higher refractive index, light travels slower. Lesser refractive index, light travels faster. Did you get it? So optically rarer and optically denser. In a rarer medium, the speed of light is faster. Which means optically rarer medium has lower refractive index value and also higher speed of light, high speed of light. Optically denser medium has a higher refractive index value, lesser speed of light. Keep that in mind. It's a little bit confusing topic, right? But don't get confused, huh? So tell me, what is the formula for refractive index? N is equal to C by V. Let's do the problems that are related to this now, right? Here, problem number one, the speed of light in a glass is given by, they had already given the speed of light in glass is 2 into 10 power 8 meter per second. It means speed of light means V value they had given. Find the refractive index of glass. It means he is asking refractive index of glass. We don't know. Find the refractive index of glass. While doing the refractive index problem, they won't give constant value, which is nothing but C value. You need to take it personally by your own. So tell me, what is the speed of light in vacuum, which is nothing but 3 into 10 power 8 meter per second, right? So tell me the formula for refractive index. N is equal to C by V. So let's do it. So here, C value 3 into 10 power 8 meter per second divided by 2 into 10 power 8 meter per second. 10 power 8, 10 power 8 get cancelled, meter per second, units, or everything get cancelled. In 2 table, 3 goes for 1.5 times, right? So the refractive index of glass is 1.5. So refractive index of glass is 1.5. 1.5 is the value for refractive index. Simple problems. These kind of problems might be asked in examination. So let's see the second question. The refractive index of water is 1.33. He just changed the model. In this time, n value had given. Now he is asking, find the speed of light in water. He is asking that, what is the V value now? You know the formula. N is equal to C by V. From this formula, V is equal to C by N. What is C value? 3 into 10 power 8 meters per second divided by 1.33, right? Here you need to multiply with 100 on both sides, numerator and denominator. You'll get 300 by 133 into 10 power 8 meter per second. If you divide 300 with 133 table, you'll get the value approximately 2.25 into 10 power 8 meter per second. So this is the speed of light in water, right? If you try this, you'll get your answer perfectly. So problem number 3, the light travels through diamond with a speed of, this time he had given V value. He had given the V value, that is 1.24 into 10 power 8 meter per second. Find the refractive index. N is equal to question mark. N is equal to C by V. C value 3 into 10 power 8 meter per second divided by 1.24 into 10 power 8 meter per second. Both get cancelled. What will remain? 3 by 1.24. Let's multiply with 100 on both sides. What do you get? 300 by 124. Yeah. And finally, when you divide it, you will get the value 2.42. So this is the approximate value of diamond. This is nothing but refractive index of diamond is 2.42. You get it? So let's see one more problem. The refractive index of medium A, here he haven't mentioned anything. Medium A is 1.5 and the refractive index of medium B is 1.33. Which medium is optically denser? So if the refractive index value is higher, if the refractive index is higher, then that medium is optically denser, which means medium A 1.5 and medium B 1.33. Among these two, which has a higher refractive index value 1.5? So medium A is optically denser than compared to medium B. So A is denser than B. So next see one more question. So here it asked the speed of light in air is V is equal to 3 into 10 power 8 meter per second. The speed of light in a liquid is, a particular liquid is mentioned, is 2.4 into 10 power 8. Find the refractive index of the liquid. At this time, we'll take speed of light in air value as a constant C value because both will be same. So let's n is equal to C by V. C value 3 into 10 power 8 meter per second divided by 2.4 into 10 power 8 meter per second. Yes. Both will get cancelled. 3 by 2.4, which means if you multiply above and up down, we'll get an answer approximately 1.25. You'll get it, right? So next question. A transparent medium has refractive index. A transparent medium has refractive index 1.6. Calculate the speed of light in that medium. V is equal to question mark. So n is equal to C by V. C value we don't know. V is equal to C by n. So 3 into 10 power 8 divided by 1.6, which means 30 by 16 into 10 power 8. So the final answer for this question is, you'll get 1.875 into 10 power 8 meter per second is the exact value for the refractive index. At this particular refractive index value, it has a speed of light value 1.87 into 10 power 8 meter per second, right? Okay. So these are all some of the problems that are related to this. So let's discuss. Up to now, we discussed about refractive index, absolute refractive index. It tells us how much light slows down when it travels from vacuum to air into a medium. So let's discuss one more related topic, that is nothing but relative refractive index. Relative refractive index. The refractive index of one medium with respect to refractive index of one medium with respect to another medium is called relative refractive index. It tells us how much light bends when it travels from one medium to another medium, right? For light traveling from medium 1 to medium 2, medium 1 to medium 2, it is n2 by n1, right? So n2 is equal to n2 by n1, which is nothing but n2 represents refractive index of medium 2 with respect to medium 1, right? It should be written like this. Refractive index of medium 2 to 1, which is nothing but n2 by n1. Don't get confused with it. So we have one more formula for this also. N21 is equal to V1 by V2. N21 is equal to N1 by N2. So we have two formulas for this, N2 by N1 or V1 by V2. So let's compare these two. N2 by N1 is equal to V1 by V2. Right? V1 is the speed of light in medium 1. It is the speed of light in medium 2. So let's understand this topic much deeper with an example. Let's take air and glass. So the refractive index of air is 1 and the refractive index of glass is 1.5. So the relative refractive index of a glass with respect to air. Relative refractive index of glass with respect to air refractive index of glass with respect to air, which is nothing but 1.5 by 1, right, which is equal to 1.5. Did you get it? So light travels 1.5 times slower in glass compared to air. So this meaning says light travels 1.5 times slower in glass compared to air. So take one more example. Glass and water. So we are given refractive index of glass is 1.5 and refractive index of water is 1.33. So refractive index of NWG is equal to 1.33 by 1.5. So when you divide these two, you will get 0.887. When you divide these two, what do you get? Water is optically rarer compared to the glass. Water is optically rarer medium than compared to the Okay, let's understand the different, which means the relation between absolute and relative refractive index, right? Let's say for no mediums, N2 by N1, right? So medium A is 1.6. Let's say medium A is 1.6 and medium 2 is 1.4. So NBA is equals NB by NA, which is equal 1.4 by 1.6. When you divide this, you will get again 0.875, right? So let's do the problems that are given in our textbooks. The refractive index of water is 1.33 NW and the refractive index of glass is 1.55. Find the refractive index of glass with respect to water. So refractive index of glass with respect to water and G 1.5 by 1.33. When you divide these two, you'll get the answer 1.3 times. 1.13 times. So let's see one more. The refractive index of diamond is 2.42. Refractive index of diamond is 2.42 and refractive index of water is 1.33. Find the refractive index of diamond. Find the refractive index of diamond with respect to water. So which means 2.42 divided by 1.33. You'll get the answer 1.82. So let's see one more problem. The problem says the speed of light in water. Say I had given now. The speed of light in water is 2.25 into 10 power 8 and speed of light in glass is 2 into 10 power 8. So when you divide these two, 10 power 8 and 10 power 8 got cancelled. You'll get 2.25 divided by 2. So we'll get 1.125 is the answer. So this is the refractive index of glass with respect to water. Right? So let's understand one more question. A ray travels from glass, a ray which is traveling from glass, and that glass has a refractive index 1.5 into water present inside, and that water refractive index is 1.33. Will it bend towards or away from the normal? Here, you don't have to do the problem now. You just simply look into it. Which is the denser medium among these two? Here, glass refractive index is 1.5 and water refractive index is 1.33. Here, glass is denser than compared to water. So, the light ray is coming from glass to water, denser to rarer medium, and the light ray is coming from denser to rarer medium. The light ray bends away from the normal. The light ray bends away from the normal. Did you get it? So this is an important question. You need to remember it. So let's close this video with some simple questions. Write the formula for relative refractive index. N21 is equals N2 by N1, or else V1 by V2. The relation has to be very clear. Right? What is the value of relative refractive index when both mediums are same? What is the value of relative refractive index when both mediums are same? If both mediums are same, when you divide those two, you will get the answer 1. Right? If relative refractive index is greater than 1, if relative refractive index value is greater than 1, what does this indicate? So if you do it, you will get the answer 2.42, which is greater than 1. This says that second medium is optically denser than the first medium. That second medium is optically denser than the first medium. You need to remember it clearly. Right? So that's it about the overall topics. So tomorrow we'll start introducing the lenses. Okay, that's